Hello everyone, today we're doing section 5, chapter 5. This is day 1, and we're going to be learning our final few identities that we have in trigonometry. The first one we're talking about in this section is the double angle identity, and this is one of the most important identities. This one you will use a lot, especially in calculus next year. This identity describes how we can take the sine, the tangent, or the cosine of twice an angle, or 2 thetas, and re-express it as just single thetas. And so it becomes really helpful when you have a coefficient on your theta inside the trig function. So notice that there's one identity for sine and one identity for tangent, but there are actually 3 different versions of the cosine double angle identity. And each of these versions will be useful in different scenarios. It's important to realize though that each of these identities is just rewritten using the Pythagorean identity. So for example, we know that sine squared is equal to 1 minus cosine squared. If we just replace sine squared with 1 minus cosine squared, we'll actually generate the next version of the identity. And conversely, if we change cosine squared theta to 1 minus sine squared theta, that would change this to the other version. So really, if you just memorize one of these double angle identities for cosine of 2 theta, you can always reproduce the other ones using your Pythagorean identities. For our first example problem, we're told that if sine of theta is equal to negative 7/25 on a certain interval, they told us the interval is from pi to 3 pi over 2, which is 180 to 270. That lets us know we're in the third quadrant. That we should be able to find what sine of twice the angle is, cosine of twice the angle, and tangent of twice the angle. So we just want to remember that we are in the third quadrant, so that means that cosine of theta is going to be negative, and the tangent of theta is going to be positive. So the first thing we need to do is we need to figure out what cosine and tangent of theta are. Because if you look in our identities here, the identities we're going to be using to find sine 2 theta, cosine 2 theta, and tangent 2 theta, we have to know what tangent, sine, and cosine all are. So they've given us what sine is. Remember, if they give you one trig ratio, you can find all the other ones. If you want to draw the triangle for this one, that would probably be the easiest way. So I'm just going to go ahead and sketch a right triangle. I was given that the sine of theta was 7/25. So that means the opposite side was 7, and the hypotenuse was 25. Okay. Since I'm in the third quadrant, I do my angle over here in the third quadrant. And when we solve for the other side of this triangle, this is actually a 7, 24, 25 triangle. Okay. So now when I find the cosine of theta, it's going to be negative. It should be the adjacent side over the hypotenuse. That's going to be negative 24 over 25. And the tangent of theta should be positive, which will be opposite over adjacent. That's 7 over 24, right? The negative over the negative makes it positive. So we have our ratios for sine theta, cosine theta, and tangent theta now. And we can use those ratios and our double angle identities to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So let's start with sine of 2 theta. Sine of 2 theta should be the same thing as twice the sine of theta times the cosine of theta. So now, if I want to know sine of 2 theta, I can just replace sine theta with its ratio. Sine theta was negative 7/25. So I'm going to type in negative 7/25. And cosine of theta was negative 24/25. Okay. So we just have to do some calculations here. Okay, when I typed in my calculator 2 times negative 7 times negative 24, I got 336. And when I typed in 25 times 25, that's 625. And that fraction does not reduce. So we're left with a pretty beast there. Sine of 2 theta is equal to 336 over 625. So that's our first double angle. Now we're going to do the same thing, but we're going to do it for cosine of 2 theta. Okay, now you have several options for what you want to use for cosine of 2 theta. Generally, I think the easiest one is cosine squared minus sine squared. So I'm just going to do cosine squared minus sine squared. And so I replaced cosine theta. We just discovered that was negative 24/25. And I'm going to square that. Minus sine was negative 7/25. I'm going to square that. So 24 squared, put that in my calculator, that's 576. It's going to be positive. And then 25 times 25 is 625. Minus, if I square this one, that's 49 over 625. And so we have a pretty basic subtraction problem here. 576 minus 49 is equal to 527. So this is 527 over 625. That's what cosine of 2 theta would be equal to. Okay. Now, for the tangent of 2 theta, you have a couple of options. You can use the double angle identity, which says that tangent of 2 theta should equal 2 tangent of thetas divided by 1 minus tangent squared of theta. And then you just plug in what tangent of theta was. Tangent was 7/24, so I do 2 times 7/24 over 1 minus 7/24 squared. So we get 14/24 divided by 1 minus, see, that's 49 over 576. So we have to do a little bit of common denominatoring there. 576 over 576 minus 49 over 576. So now we can subtract those. 576 minus 49 is 527. So we get 527 over 576. And above that is still 14/24. Keep, change, flip. Reduce. We're going to get that this is equal to 336 over 527. Okay, now there's a much easier way to do that. Since you've already solved for the cosine of 2 theta and the sine of 2 theta, we know that tangent of 2 theta is also equivalent to sine over cosine. So we could have just plugged in our two solutions we had there in a fraction. This is generally the faster and easier way of doing it. So then we just type it in as 336 over 625 divided by 527 over 625. And that, when we keep, change, flip, those will cancel, and so we get 336 over 527. Same thing. Okay. Try this one on your own. It gives you the ratio for cosine, and it wants you to find sine 2 theta, cosine 2 theta, and tangent 2 theta. We are in the first quadrant, so everything's positive. Okay, I solved for sine and tangent using a right triangle. Hopefully you got that sine theta was 4/5 and tangent of theta was 4/3. And now we're ready to use our double angle identities. Sine of 2 theta is equal to 2 sine theta cosine theta. So we just plug in 2 times 4/5 times 3/5. 2 times 4 times 3 is 24. 5 times 5 is 25. So sine of 2 theta is 24/25. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta. So if I plug in cosine, that's 3/5 squared minus sine theta was 4/5 squared. That's 9/25 minus 16/25. So we get negative 7/25. Okay, so that's my cosine. And then lastly, again, the easiest way to solve for tangent 2 theta, we'll just do the simple method. Since you already have sine and cosine, you might as well just do sine over cosine. So I'd do 24/25 divided by negative 7/25. Keep change flip, you end up getting 24 over negative 7. Okay. All right, one last problem for this section. The last thing we're going to do is we're going to solve an equation using our double angle identities. If you notice in this equation, when we have sine of 2 theta minus sine of theta equals 0, we're going to be solving for everything from 0 to 360 degrees. We couldn't solve these before because we didn't have any way of modifying sine of 2 theta. Now I know that I can rewrite this as a single theta by changing it to 2 times sine of theta times cosine theta. And if you look at those two terms, we can see that each of the terms we have a common factor of sine theta. So we can factor out sine theta. And then we're left with 2 cosine theta minus 1. It's equal to 0. Now we use our zero product property and say sine of theta equals 0, or 2 cosine theta minus 1 equals 0. We solve for everywhere where sine is 0. That would be at theta is equal to 0 and pi. And if we solve this one, we're really solving for when cosine of theta is equal to 1/2. Cosine is going to equal 1/2 at, let's see, pi over 3 and 5 pi over 3. So those are our solutions. Okay. Go ahead and try these two practice problems on your own. Okay, so here's the solutions to the last set of problems. For cosine of 2 alpha, again, this is my preferred one to use, change it to cosine squared minus sine squared. And I especially use that because I noticed that I had a negative sine squared there. Those are going to cancel out really easily once you put a negative sine squared in there. So I added the sine squared over, that turned to 0. Solved for cosine squared. I got when cosine of alpha is equal to 0. Over the interval, that's at pi over 2 and 3 pi over 2. And then for the tangent one, we changed tangent of 2 beta to 2 tangent betas divided by the quantity 1 minus tangent squared beta. So since I didn't want to work with a fraction anymore in my equation, I multiplied both sides by the denominator. That's in blue. And then started canceling from there. Now on this side I wanted to set it equal to 0, so I subtracted the 2 tangent betas over, factored out a 2 tangent beta, and I was left with 1 tangent squared beta minus 1. The 1's canceled out, and so you're left with the zero product property. Tangent of beta is either equal to 0 or negative tangent squared beta is equal to 0. Since that's essentially the same thing when you solve for tangent over here, you get tangent of beta is equal to 0. Your only two solutions are at 0 and pi, where tangent is 0. Okay. That concludes our lesson on double angle identities. We will be working with them lots more. Have a great day.